Hello everyone. Hope everyone is doing well. Today we're going to talk about elasticity of demand. We're going to see the definition of elasticity of demand and we're going to see where is it used. So the definition, elasticity basically means how does one variable respond when another one changes. So when we look at elasticity of demand, it's basically telling us what is the responsiveness of quantity demanded when price changes. So it is telling us if price changes, since we said that people decide when what they want to purchase from the demand chapter. It could be that they wanted to purchase a certain good, but they look at the price and then they decide whether they will purchase it or not. So we're seeing is like whether how responsive are people. If price increases or decreases, how much do their quantity demanded change? Now, the reason why we use it is, let's say we're looking at demand curves. So we have our price and our quantity. Then, this could be a demand curve. Demand curve is always downward sloping, as we said. This could be a demand curve, or it could be something like this, a very steep demand curve. Now, all these three are demand curves, but you see, like the slope is different. So the responsiveness, so if we have the same price change, let's say price changes from here to here, we will see that in the very flat demand curve, the response to quantity demanded is a lot more than the response to quantity demanded of a very steep demand curve. So elasticity helps us to understand that. Now we are going to use a formula to understand what is elasticity. So the formula for elasticity of demand is, we'll call it ED equals, let's actually write it in an equation that would be in using equation editor. So that is the formula of elasticity of demand. So if percentage change of quantity demanded divided by the percentage change in price. So again, if I draw a demand curve like this, and if let's say this was the price, if let's say price increases by 10%, whereas quantity decreased by 5%, then my elasticity of demand would be percentage change in quantity demanded, which is 5%, divided by percentage change in price, which is 10%. So it would be 0.5. Notice we are actually not using the negative sign. Technically, there should be a negative sign. If one price goes up, the quantity should go down. So there should be a negative sign here, but since it is elasticity of demand in a lot of books, they drop the negative sign because we know it is going to be negative all the time. So we just drop the negative sign here. So this is how we would calculate elasticity. Now let's look at an example to see exactly how we would calculate elasticity. So let's say we use the same graph here. Let's say that we are using, in our case, let's say price went up from $5 to $10. And at $5, my quantity demanded was 50. And then by $10, my quantity demanded fell to 30. So what is the elasticity of demand in this case? Now, if we use the conventional change in percentage change in quantity demand and percentage change in price, we would find, okay, well, in my case, percentage change, the delta sign stands for change in quantity demanded would be, since it's a price increase, so the new price minus the old price, so which is 30 minus 50 divided by, new quantity minus the old quantity divided by the old quantity times 100. That would be 20 over 50. There's a negative times 100, which comes out to be negative 40%. Okay, and then the percentage change in price would be, since it's a price increase, so it's 10 minus 5 divided by 5 times 100, which is going to be 100%. So then my elasticity, I would say at this price point would be percentage change in quantity demanded, which is, I'm dropping the negative sign, so 40% divided by 100%, which comes out to be 0.4. However, let's say we are now seeing a price decrease. So we're moving from $10 to $5. And so the quantity will be increasing from 30 to 50. So my percentage change in quantity demanded, since we're not using the negative sign, we're dropping it. So the numerator will basically be the same. It would be, instead of negative 20, it will be positive 20. Then the change in quantity would be, instead of 50, it will be, since we're moving from 30 to 50, it will be divided by 30 times 100, which is going to be, so this becomes 66.6%. Same thing, since I'm going down in price, so my new price is $5, so the numerator is going to be the same. We are just not going to use the negative sign. The denominator now would be 5. Sorry, the denominator is now going to be, not 5, it's going to be 10. So then my price change would be 50%. So then my elasticity is going to be percentage change in quantity demanded, which is 66.67%, divided by percentage change in price, which is 50%, which actually comes out to be 1.334. Now that's a problem. We're moving along the same two numbers, same two prices, and the same two quantities, yet we get two very different elasticities. We get 0.4 in one case if it's a price increase, we get 1.334 if it's a price decrease. That's a problem then. So what we do is, instead of using this method of percentage change in quantity demanded and percentage change in price, we use what we would call the midpoint method. So in the midpoint method, so let's say in our case, we're moving from 30 to 50. The midpoint method says, so the percentage change in quantity, the numerator stays the same. So it would be, let's say if it's an increase or a decrease, let's say it's going from 50 minus 30. Now the denominator, instead of being the initial value, it will be the average between these two numbers. So the average of 30 and 50 is going to be 40 times 100. So this ensures that no matter if it's a price increase or decrease, the quantity is going to be moving between these two numbers, and the midpoint is always going to be the same. So the answer we get will be, which is going to be 50%. And the same thing we do with price. So let's write it in a nicer way, go down the steps, and then we can find out, we can calculate elasticity. So let's say we will use the midpoint method to find elasticity. So what are the methods? So one is, first step is find the midpoints of price and quantity. So in our case, the midpoint of price, how would we do that? Let's say we would find, let's call it PM. So it's going to be the two prices, so change in price. Actually, it will be the sum of prices. So in our case, 10 plus 5 divided by 2, which would be 7.5. So it's either, we can call it midpoint, or if you want to call it, you can also call it the average. And then we can also find the midpoint of the quantity, which is going to be the average of the quantity. So it's going to be, so I will name this QM. It's going to be 30 plus 50 divided by 2, which is going to be 40. So that's my first step. The second step is find the percentage change in price and quantity respectively. So if I wanted to find that, I would say insert, let's say PCT of price equals the change in price divided by the midpoint, which we just calculated, which is 7.5 times 100, which comes out to be 66.67. So then, and then the percentage change in quantity would be 50 minus 30 divided by the midpoint is going to be 40 times 100, which comes out to be 50%. So then, as you can see, the midpoint, I'm using this number down here instead of the initial value for when finding the percentage changes, and this value goes down here. So then finally, elasticity would be, which is going to be this formula, percentage change in quantity demanded divided by percentage change in price, which is going to be equal to Percentage change in quantity was 50%, divided by the percentage change in price is 66.67%. So let's write 50% on top of here and delete this. And so we get the answer to be around 0.75. So then instead of having confusion as to what is elasticity, if it's a price increase or a decrease, we will say elasticity of demand is going to be 0.75 between price changes between these two prices. So after that, now the next thing we need to know is what affects elasticity. So like, what are some of the factors that could affect elasticity? Factors that affect elasticity, like when is it a bigger number, when is it a smaller number? So we can see that, usually what's happening here is as price changes, are we more responsive to quantity demanded? So here it's showing us, this number is telling us that, let's say, if price increases by 1%, then quantity demanded falls by 0.75%. This is what this number that we just calculate is telling us. So that means if price goes up by 1%, my quantity demanded falls by 0.75%. Or I could also say if price decreases by 1%, then quantity demanded will increase by 0.75%. So what factors affected? So this is telling us that whatever the change in price, this response is less than the change in price. So let's think about some products. So let's say that if you have something that is very essential, like electricity, we need electricity almost on a daily basis to keep our homes cool, to watch TV, or to run our computers, or to work, or to do any other things. So if it's electricity, then if price goes up, we still have to consume it. We may lower it a little bit, consumption a little bit, but not by a lot. So we won't like completely, if price goes up by 10%, we won't lower our consumption by 20 or 30%. We may lower it by maybe 1 or 2%. Now imagine instead of electricity, let's say if I have something like maybe a vacation. If airline prices go up, then, I may think that, okay, well, it's a little too expensive for me to take this trip. I may do something else. I might just do a staycation, or I may just go drive somewhere for my vacation, or I might do something else. So then, in that case, I may not take that vacation. So if airline prices go up, then holiday travel may fall by a large extent. So then from here we can see that the more essential the good is, the lower will be the elasticity. So from this example we can see is the more essential the good is, the lower will be the elasticity. So if we have something like that going on, then if some goods are extremely essential, like electricity, gasoline, so those have very low responses of quantity demanded to changes in price. So let's look at another example. Let's say we have, again, electricity. Let's say electricity is remaining high in price. So initially, I may just bite the bullet and, just lower my electric consumption a little bit. But eventually, in the long run, I may just buy solar panels to offset the high cost of electricity. So basically, I might just think that, okay, I'm just going to use solar panels because electricity is very expensive. So if electricity remains high in price, then in the long run, I would change that. So another thing that affects elasticity is lower in the short run, and it can be higher in the long run. So it's basically, in the short run, if it's an essential good, I may have to just bite the bullet and just take up just pay for the higher cost. But in the long run, I may have a choice. I may just start buying solar panels. So another thing is how broadly the good is defined. So if we talk about, let's say, food, we need food for survival, then we know that if price of food in general goes up, we still have to buy food. Let's say price of every item in food goes up, then food will have a low elasticity. On the other hand, if I talk about a very narrow definition, so let's say, however, if price of fish goes up, just fish, I may substitute fish for meat or for other protein like tofu. So if the good is narrowly defined, elasticity is higher in value. So these are the few things. So we can say the broader the good is defined, the lower is the elasticity. So these are the factors that could affect elasticity. Now let's look at what are some of the types of elasticity that we have. Now, depending upon the curve, we may have different types of elasticity. So let us look at some of the types, because the shape of the the shape of the curve can affect how we interpret the use of that good. So let's say we have price and quantity. So let's look at the first extreme. Although we said demand is never it's always going to be downward sloping, but there are a couple of extreme cases where we will it's called perfectly inelastic. So perfectly inelastic demand is when your demand curve is going to be a vertical line. So it's going to be a line like that. That's going to be your demand curve. So basically, no matter what the price is, quantity is always going to be, let's say, 50. So price can go up from 10 to 100, but your quantity is not responsive at all. So in this case, you see, change in quantity is 0. So if I calculated my elasticity, percentage change in quantity is always going to be 0, divided by the change in price can be any number. So it can be any number, let's say x, so your elasticity will be 0. So here, elasticity is going to be 0. For these goods, so some examples of a good that has perfectly inelastic demand are like medicines. So if I need some medicine, I must have it on a daily basis or a weekly basis. If I don't, I may have other adverse health effects. So no matter what the price is, I have to buy a specific dose of that medicine. So this is perfectly inelastic demand, and this is good for business, because if your product has perfectly inelastic demand, you can charge any price and you know that people will have to buy that product. Now, after that, we have another kind of demand, which is not as extreme, but we'll call it inelastic demand. Here, the demand curve is going to be between 0 and, again, remember, since we're dropping the negative sign, so we're not going to put the negative sign in. In this case, the demand curve is going to be kind of steep. So what it means is that the percentage change in price, whatever the change in price, the change in quantity will be less than that. So if price changes by, let's say, 10%, quantity will be changing by 5%. So it will be some number less than 10%. So my elasticity of demand here would be 5% divided by 10%, which is 0.5. So these products are essentials for us because, they're not as essential as perfectly inelastic demand, but we still need them on a daily basis. So examples are like gasoline. We have maybe food, or let's say food groups like proteins, or we need like electricity, things like that. The third one is going to be unit elastic. Unit elastic is where quantity and price changes in the same proportion. So let's say if price changes by 10%, quantity will also change by 10%. So in our case, the next one is unit elasticity or unit elastic demand, where elasticity of demand equals 1. There aren't really specific examples for this product. It's just something we note that, this is where if price goes up by a certain proportion, quantity grows up by a certain proportion. We may use one example, maybe housing. So if price of 1 square foot goes up by 1%, we may lower our demand for housing by 1% because our demand for housing area, because we may want to spend a certain amount, let's say $300,000 or $500,000 to buy a house. So if price of that housing goes up, we want to spend exactly that amount, so we cannot go over the limit, so we tend to buy a smaller house. So housing could be one example of unit elastic demand. Finally, we may have elastic demand, where elasticity of demand is greater than 1. These are products that have a lot of substitutes. So basically, if your demand if it is very flat, then if price goes up by 10%, your quantity response will be much, much more than 10%. So it would be, let's say, 30%. So elasticity of demand would be 30% divided by 10%, which is going to be 3. So actually, I also forgot another factor that affects demand is substitutes. So the more substitutes a product has, the higher is the elasticity. So this is telling us, like, if we go down here, let's think about cornflakes. We usually eat that for breakfast. It has a lot of substitutes. So we don't need cornflakes for breakfast. We can have rice flakes, or we can have Captain Crunch, or any other cereals. But that's not it. We can also have maybe not any cereals. We can have eggs on toast. We can have a bagel. We can have just maybe cold pizza for breakfast. So it has a lot of substitutes. So in that case, there's a pretty high elasticity for cornflakes. On the other hand, if you think about gasoline, gasoline does not have much of a substitute. Proteins, we need proteins for us, so it doesn't have much of a substitute. Electricity doesn't have a substitute. Medicines, of course, does not. So they will have much lower elasticity. And then finally, we have perfectly inelastic demand. This one, it's going to be, the elasticity will be absolutely horizontal in shape. So instead of a vertical line, we will have a horizontal line. So it will be like that. So that's going to be my demand curve. It should be a straight line. And so this one, no matter what the change in quantity is, price does not change. So this is going to be, let's say, like things like, eating at a buffet. No matter, you just pay one price to enter, but then you could eat 0 plates of food, 1 plate of food, 5 plates of food, and it doesn't really change according to your quantity. Could be any amount, but you still pay the same price. Or like, going to an amusement park. You pay 1 fee to enter, and it doesn't matter how many rides you take, you are going to pay the same amount. So this is like some of the types of elasticities we have. And now finally, let's talk about why do we need elasticity. So elasticities help us. If you're a company, it helps us to understand, like, how loyal are your customers. So it's telling us, so if your elasticity is higher, let's say it's greater than 1, then your customers will leave you if you have a price increase. However, if your elasticity is low, which is, let's say, less than 1, then your customers will remain with you even if you increase prices. Another way of thinking, so let's say you are facing some cost increases and you're thinking, should I increase prices of my product? So we know this is the formula for elasticity. Now, if it is, you have an elastic product, which means that elasticity is greater than 1, that would imply, let's say, that if your elasticity is greater than 1, then your percentage change in quantity demanded is going to be greater than your percentage change in price. So in that case, what that means is no matter what you change your price as, so if your price increases by 5%, your quantity demand will change by more than 5%, by 10% or 15%. So if you remember in one of the videos that I have, we talked about revenues. Revenues equals price times quantity. And we know that in a demand curve, price and quantity moves in opposite directions. So now when you have elastic demand, it's telling us if I increase my price a little bit, my quantity will fall by quite a lot because elasticity is greater than 1. So what it does is it actually reduces your revenues. So if I write it up here, if I have elastic demand, then an increase in price will reduce my revenues. On the other hand, if my elasticity is inelastic, so if it is less than 1, then the opposite is true. That means if I increase my price a little bit, or by a lot, my quantity demanded will fall, but not by much, by a little bit. So in that case, my revenues will actually go up. So if I have inelastic demand, then an increase in price will actually increase my revenues. So if I'm a seller of a product, I would really like to know what my elasticity is, because it helps me to understand whether changes in my price of my product will help me earn more revenues or less revenues. Hopefully this was helpful, and if you have any questions, you can leave a comment below and I'll get back to you soon. Have a good rest of the day. Goodbye.